Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are dealing with the chapter Ionic Equilibrium. Today in this session, I am going to solve some PYQ of JEE Main on the topic common ion effects, solubility, and solubility product. Let us start the session. Right? So here is the question given, which is given in 2014. What is the question? Solid barium nitrate is gradually dissolved in 1.0 into 10 power minus 4 molar Na2CO3 solution. At what concentration of Ba plus 2 will a precipitate begin to form? So this is the question. What did he ask? See, let us see here. This is container. Okay. So this is container containing already Na2CO3 solution. It is containing what solution? Na2CO3 solution. Whose molarity is, whose concentration is, that means what you can write, Na2CO3 solution concentration is given as how much? 10 power minus 4 molar. Into the solution, what is being dissolved? What is being dissolved? You are adding into this. What you are adding gradually, slowly you are adding a BaNO3 taken twice. Solid you are adding. You are adding solid into the solution. What happens? Barium nitrate, what is that? Barium nitrate solid will dissolve in it. Dissolve in this Na2CO3 solution. Okay. So he is asking at what concentration of Ba plus 2 will a precipitate begin to form? Okay. Another data is given to us. What is the data? KSP is given. KSP for whom is given? Barium carbonate. So here, who is sparingly soluble salt? The salt for whom KSP is given, that is sparingly soluble salt. So here, sparingly soluble salt. Who is sparingly soluble salt? Barium carbonate. Why? How did you identify that it is sparingly soluble salt? Because KSP is given for that solubility product. So precipitate. Whose precipitate? Precipitate belongs to barium carbonate. Barium carbonate. So now barium carbonate dissociates to form what? Ba plus 2 plus CO3 minus 2. If you want KSP of whom? Barium carbonate. How do we write? We write it as Ba plus 2 concentration into CO3 minus 2 concentration, right? From the concepts of solubility and solubility product, we have studied that when KSP is equal to QSP. What is QSP? Ionic product. KSP is solubility product, whereas QSP is ionic product. Then precipitate of the sparingly soluble salt will begin. Precipitation of sparingly soluble salt will begin. Okay. right? So now you have to see that KSP is equal to QSP. This condition you have to check. If you check this condition, what is QSP? Generally, we know that QSP is written at any stage of the dissolving of the salt. QSP is written at any stage of dissolving of salt. Okay, so for the salt, barium carbonate, see BaCO3 gives rise to, what is that? Ba plus 2 plus CO3 minus 2. What you will write? QSP. QSP is also same. What is that? Concentration of Ba plus 2 and CO3 minus 2. Now instead of this Ba plus 2 and CO3 minus 2, can I write QSP? Yes, I can write. KSP is equal to QSP. If I know the concentration of Ba plus 2 and CO3 minus 2, then I can substitute here and I can equate with KSP, right? So now what is given here? Solid barium nitrate is gradually dissolved in 10 power minus 4 m Na2CO3 solution. So Na2CO3 is strong electrolyte. So Na2CO3 dissociate completely into 2 Na plus and CO3 minus 2. So Na2CO3, how much concentration is given? 10 power minus 4 molar. So 10 power minus 4 molar dissociates. As it is dissociating completely, what will be the concentration of sodium ion? 2 into 10 power minus 4 molar. What will be the concentration of carbonate ion? 10 power minus 4 molar. Now we know carbonate ion concentration. We know this carbonate ion concentration. I want a Pa plus 2 concentration. So if I want Pa plus 2 concentration, this is the condition. PPT begin to form. Okay. So now I can write Ba plus 2 concentration is equal to KSP by CO3 minus 2 concentration. Okay, so KSP given as how much KSP is given? KSP is given as 5.1 into 10 power minus 9 by, what is the carbonate concentration? Here you can find it. Okay, how much it is? 10 power minus 4. Okay, so then what you get? 5.1 into 10 power minus 9 into 10 power plus 4, that is equal to 5.1 into 10 power minus 5. This is the concentration of Ba plus 2. So we have equated solubility product with the ionic product. Ionic product is written in this way, you know that. So why did we equate at that, from that point, from that situation, from that condition, precipitate starts forming. So QSP, you know, barium plus 2 concentration into CO3 minus 2, that is what we have written here. Already it is written here. QSP is equal to, so that we have substituted and got the answer. Okay. So what will be the answer? Second option. So let us move to the next question. So when is this question given? This question is given in 2018, right? So let us see. An aqueous solution contains an unknown concentration of Ba plus 2. Okay. Let us see here. Here what is there? There is Ba plus 2 solution. Ba plus 2. Right? So we do not know the concentration of Ba plus 2. Initially, Ba plus 2 concentration, initial concentration is not known. I represents here initial concentration, simply. for the purpose of understanding. Now what is done when 50 ml of 1 m solution of Na2SO4 is added, BaSO4 just begins to precipitate. Now what is added into this? There is another solution. Okay, there is another solution. What is the solution? Na2SO4, whose concentration molarity is equal to 1 molar and volume is equal to 50 ml. This is poured into this, right? Now these two are mixed, and when they are mixed, just begins to precipitate. Who is just beginning to precipitate? BaSO4 is just beginning to precipitate. So here sparingly soluble salt is what, and solubility product is also given for BaSO4, you see. So here sparingly soluble salt is what? BaSO4, right? So BaSO4 begin to start precipitating. So what is that condition? KSP is equal to QSP. When KSP is equal to QSP, then the sparingly soluble begin to precipitate. Okay, the final volume is 500 ml. After mixing these two, volume final is equal to 500 ml. That means you are mixing how much here? 50 ml. Then what will be this volume? Volume of this total is 500. So volume of this will be 450 ml. Initially, barium is present, Ba+2 is present in a solution whose volume is equal to 450. How did you obtain it? By adding this 50 ml, that final volume has become 500 ml. So this must be 450 ml. So this is the question given. Then what is the original concentration of Ba+2? So initially, what is its concentration? This is the question what is asked. Okay. Now Na2SO4, here what we are speaking? We are speaking about the Na2SO4 solution. Speaking about Na2SO4 solution. Na2SO4. Right. So what will be the volume is equal to 50 ml and the molarity is equal to 1 molar. You know that molarity is equal to number of moles by volume in liters. Okay. Now number of moles in this solution is equal to, or otherwise you can also calculate like this. Now when you are adding this to this, the volume has become 500 ml. That means it is being diluted. It is being diluted. So let me take it as what? M1 V1. Now when you add this Na2SO4 into Ba+2 solution, volume V2 became 500 ml, and I want final concentration of Na2SO4. From the concept of dilution, we know that what do we know? M1 V1 is equal to M2 V2. M1 is 1 into 50 ml is equal to M2 is equal to, we need to calculate into volume. Final volume has become 500 ml. Because when they are added, now Na2SO4 is in 500 ml after adding, then what do you get? M2 will be equal to 50 by 500, that is equal to 1 by 10, that is equal to 0.1 molar. So when it is added, now in the solution, the concentration of Na2SO4 is 1 molar. Concentration of Na2SO4 after mixing is 0.1 molar, right? So 0.1 molar. So let us, what will be the concentration of SO4 then? We know that Na2SO4 dissociates completely to form 2Na plus SO4 minus 2. Is that okay? So now the concentration after mixing is how much? 0.1 molar. So this will give you 2 into 0.1 molar sodium ion concentration and 0.1 molar sulfate ion concentration. Now we know sulfate ion concentration. What do we know? We know sulfate ion concentration. How much is that sulfate ion concentration? 0.1 molar. 0.1 molar. So for the sparingly soluble salt BaSO4, if you write dissociation, its dissociation, it dissociates into what? Ba plus 2 and SO4 minus 2. Okay. Ba plus 2 and SO4 minus 2. KSP will be written as KSP for this BaSO4 is equal to Ba plus 2 concentration into SO4 minus 2 concentration in a saturated solution. When will we write KSP? We write KSP for a saturated solution. Now if I go with Ba plus 2 concentration is equal to KSP by SO4 minus 2 concentration, right? So KSP is given as here, let us say 1 into 10 power minus 10, 1 into 10 power minus 10 by sulfate concentration we have calculated it as 10 power minus 1. Okay, so then that will be equal to 10 power minus 9 molar, whose Ba plus 2 when in the mixer. After mixing. What is that? After mixing. So let us take here, this is the container initially. This is the container initially, right? So here Ba plus 2 is there. Initial Ba plus 2 concentration. Ba plus 2 concentration, initial we don't know. And we know volume. Volume is equal to 450 ml. Final concentration we know that. Ba plus 2 finally, after mixing it is found that 10 power minus 9 molar. And final volume we know 500 ml. So 450 ml is converted into 500 ml. Again it is being diluted. According to theory of dilution again, we can write from the law of dilution, I can write it as M1 V1 is equal to M2 V2. That is M1 V1 is before the dilution, M2 V2 is after the dilution. Anyone you can take, it doesn't matter. So let us take this as 1 and this as 1, this is 2. So M1 we want, V1 is 450 ml. M2 we know 10 power minus 9 into volume is 500 ml. Okay, ml cancel and M1 is equal to 10 power minus 9 into 500 by 450. So on cancelling, what you get is 1.1 into 10 power minus 9 molar. So this is the concentration of barium initial. In the initial solution, that will be the concentration. How much did we get? 1.1 into 10 power minus 9 molar. Okay. Let us solve next question. So here is the question which is answered in 2019, right? If Ksp of Ag2CO3, so here sparingly soluble salt is silver carbonate is 18 to 10 power minus 2, molar solubility of Ag2CO3 in 0.1 m AgNO3. AgNO3. So first of all, let us calculate its solubility in water. In water. So let us take Ag2CO3 dissociates into 2Ag plus CO3 minus 2. Okay. So where is this all? This is in water, pure water. There is no other salt. So this is in water. Dissociation in water we are speaking. If solubility of Ag2CO3 is S moles per liter, then the solubility of what will be the concentration of Ag plus formed 2S moles per liter and carbonate S mole per liter. Right? Then what will you write? Ksp? Ksp of Ag2CO3 is equal to Ag plus concentration square into CO3 concentration, CO3 minus 2 concentration. Then that is equal to 2S square into what? S Ksp. So what will be the solubility? Solubility will be equal to Ksp by 4. One more step let us write. Otherwise we may not understand. So Ksp is equal to 4S square into S, which is equal to 4S cube Ksp, right? So S is equal to Ksp by 4 whole power 1 by 3. Okay. So Ksp given already. What is Ksp given? 8 into 10 power minus 12. So solubility is equal to 8 into 10 power minus 12 by 4 whole power 1 by 3. So 4 2's 2 power 1 by 3 into 10 power minus 12 power 1 by 3. So 3 4's 12. Then 2 power 1 by 3 into 10 power minus 4 mole. Okay. So now what did you calculate? We have calculated the solubility of Ag2CO3 in water. But the question is not that. Question is not that. The question is the molar solubility of Ag2CO3 in 0.1 m AgNO3. That means who is present? Ag2CO3. Ag2CO3 gives rise to 2Ag plus CO3 minus 2. S molar 2S. Yes, this already we have seen. Along with this, there is also AgNO3. Who is there in the solution? AgNO3. AgNO3 is strong electrolyte. It dissociates into Ag plus and NO3 minus. Okay. So now in the container, both of these are present. Who is present? Both these salts are present. One is sparingly soluble. Who is sparingly soluble? AgCO3 is sparingly soluble, whereas AgNO3 is strong electrolyte, dissociates completely. Now let us see here. AgNO3 0.1 molar is given. As it dissociates completely, 0.1 molar dissociates completely, give you 0.1 molar and 0.1 molar, right? Now let us write Ksp for this. Ksp of Ag2CO3 is equal to Ag plus concentration power 2 into CO3 minus 2 concentration. This one. So Ag concentration is 2S plus 0.1. Right? So 2S plus 0.1 square into carbonate is S concentration. Ks. Okay. Now you say solubility already we have calculated. It is in the range of 10 power minus 4. It is in the range of 10 power minus 4. So here when you compare this 10 power minus 4 into 10 power minus 4 and 0.1, see, now you are comparing these two. What you are comparing? 2s. 2s is 2 into, okay, right? See, let us compare this. 2s. 2s is 2 into, before we have calculated s here, let us see. 2 power 1 by 3 into 10 power minus 4. So it is in the range of 10 power minus 4. 10 power minus 4 means 1 by 1, 0, 0, 0, 0. This much. Now you compare this 10 power minus 4, which is equal to 0.0001 with 0.1. So 0.0001 is very much less than 0.1. So I can consider that 2s plus 0.1 is equal to 0.1. Because I am neglecting this 2s because it is very much less. So directly I can take it as KSP is equal to 0.1 square into S. So S is equal to, how much KSP is given? Already we have seen 8 into 10 power minus 12, 8 into 10 power minus 12, right? By 0.1 square. Okay, then what do you get? 8 into 10 power minus 12 by 10 power minus 2. That is equal to 8 into 10 power minus 10. So initial solubility is in the range of 10 power minus 4, but due to common ion effect. So are you finding common ion? Ag plus, Ag plus. So due to common ion effect, what happened? Solubility of Ag2CO3 has been decreased. See, 10 power minus 4 is greater or 10 power minus 10 is greater? 10 power minus 4 is greater. In water, its solubility is more. The solubility of Ag2CO3 in water is more. But the solubility of Ag2CO3 due to common ion in a solution of 0.1 molar AgNO3, its solubility has been decreased. 10 power minus 10 is smaller when compared to 10 power minus 4. So, based on common ion effect, here we are finding that the solubility of sparingly soluble salt has been decreased due to common ion effect. So, the answer is 8 into 10 power minus 10. So, answer here is what? 8 into 10 power minus 10 molar, right? So, let us see the next question. So, if the solubility product of zirconium phosphate is denoted by KSP and its molar solubility is denoted by S, then which of the following relation between S and KSP is correct? Okay, so what is given? Zirconium phosphate. Okay, how is this formed? Zr plus 4, PO4 minus 3, on crisscrossing we get the salt. That means zirconium carries what charge? Plus 4. Phosphate carries what charge? Minus 3. Okay. So on dissociation, what do you get? So zirconium phosphate is sparingly soluble salt because KSP is asked. So 3Zr plus 4 plus 4PO4 minus 3. Okay, already is given the molar solubility of zirconium phosphate is S moles per liter. If solubility of zirconium phosphate is S moles per liter, then what will be the concentration of zirconium ion? 3 into S mole per liter. This one will be 4 into S moles per liter, right? We know KSP. How to write KSP for zirconium phosphate? KSP is equal to concentration of zirconium ion power 3 into concentration of phosphate ion power 4, that is equal to, so 3s whole cube into 4s whole power 4, that is equal, because zirconium concentration is 3s, phosphate concentration is 4s. Okay, then what do you get? 3 cube 27 s power 3 into 4 fours 16 16 4 64 16 64 fours 250 4 4 16 24 256, so 256 s power 4 ksp. So ksp is equal to, what do you get? 27 into 256 s power 7. Okay, so now ksp is equal to, if you multiply this, what do you get? 6912 s power 7. S power 7 is equal to ksp by 6912, and s is equal to ksp by 6912 whole power 1 by 7. Understood? So this is the answer. So where is the answer? This is the answer. When it is asked, JEE Main 2019. Okay. Understood. Let us move to the next question. Asked in 2019 again. The molar solubility of cadmium hydroxide is 1.84 into 10 power minus 5 molar in water, in pure water. The expected solubility of cadmium hydroxide in a buffer solution of pH is equal to 12. So first of all, in water, let us calculate. We know cadmium hydroxide, okay, dissociates to form Cd plus 2 plus 2OH minus. Where is this dissociation? This dissociation is happening in where? Water. This container contains water. In that water, this dissociation is happening. Okay, sparingly soluble salt. Now, what is given? Let S moles per liter is the solubility of calcium hydroxide. Then what is this? This also will be S mole per liter, and this will be 2S mole per liter. Okay, because 1 dissociates to form 1, but here it gives 2. Okay, so let us write the relation between Ksp and solubility. So now you know that Ksp is equal to Cd plus 2 concentration into OH minus ion concentration power 2, that is equal to Cd concentration is S into OH minus 2 concentration is 2S whole power 2, that is equal to, what do you get now? S into 4S square, 4S cube. So we got Ksp as 4S cube. So 4 into solubility is already given. How much solubility is given? The molar solubility of calcium hydroxide is 1.84 into 10 power minus 5. Much? 1.84 into 10 power minus 5 whole cube. Then what do you get Ksp? We got Ksp as 4 into 1.84 whole cube into 10 power minus 15. So now we know Ksp. Now what he is asking? The question is that the expected solubility. Solubility is asking in a buffer solution of pH is equal to 12. So when pH is equal to 12, what will be H plus ion concentration? H plus ion concentration is equal to 10 power minus pH. That is equal to 10 power minus 12 H plus ion. And we know that at 25 degrees centigrade, H plus ion concentration into OH minus ion concentration is equal to 10 power minus 14 mole square per liter square. Then I can get OH minus ion concentration is equal to 10 power minus 14 by H plus ion concentration. H plus concentration is minus 12, that is equal to 10 power minus 2 molar. Now we have OH minus ion concentration. So here cadmium hydroxide, again cadmium hydroxide is dissolving Cd plus 2 plus 2OH minus. But now already in the solution, who is present? Already in the solution, OH minus ion concentration is there. How much OH minus ion concentration is 10 power minus 2. 10 power minus 2. And we know that S moles per liter produces S and 2S. Now write KSP. KSP is equal to, Cd plus 2 concentration into OH minus ion concentration square. And that is equal to, what do you get? S into 2S plus 10 power minus 2 square. Right? KSP. OH minus ion concentration is 2S from CdOH taken twice, and it is equal to 10 power minus 2 from buffer solution. Are you getting this? Right? And anyway, you know that solubility is already given. It is in the range of 10 power minus 5. 10 power minus 5. So S is in the range of 10 power minus 5. Already given 1.84 into 10 power. 1.84 into 10 power minus 5. Here it is given. See, already given in the question. When you compare it with 10 power minus 2, 10 power minus 2, compare it with 10 power minus 2, it is in the range of 10 power minus 5. So yes, when compared with 10 power minus 2 is very much less than 10 power minus 2. S is 1.8 into 10 power minus 5. 1.8 into 10 power minus 5 is very much less than 10 power minus 2. So I can write that 2s plus 10 power minus 2 can be taken as 10 power minus 2 directly. Okay. So I am considering here as KSP is equal to S into 10 power minus 2 whole square. Okay. Then solubility, what do I get? I get solubility as KSP by 10 power minus 4. 10 power minus 4. So S is equal to, already we have KSP here. How much? 4 into 1.84 whole cube into 10 power minus 15 by 10 power minus 4. Okay. So then I get so 4 into 1.84 whole cube into 10 power minus, if it goes up, you get it as 10 power minus 11. So solubility. So solubility is equal to, if you multiply this 4 into 1 point, okay, you get to 24.9 into 10 power minus 11 molar. This can be written as 2.49 into 10 power minus 10 molar. Okay. So where is that option? The option is here. 2.49 into 10 power minus 5. So in water, its solubility is 10 power minus 5, in the range of 10 power minus 5. But when you are dissolving it, when you are having common ion, so is there common ion here? Yes, there is common ion. See, OH minus here, common ion, we are having common ion. These two are common ions. So due to common ion, automatically what is happening? Solubility is decreasing. Originally, the solubility is in the range of 10 power minus 5, but here it is in the range of 10 power minus 10. So due to common ion effect, once again I am saying that it is being repeated. Okay, so you need to remember that due to common ion, the solubility of that sparingly soluble salt decreases. Understood? Okay, so let us move to the next question. So here, what is the molar solubility of aluminium hydroxide in 0.2 molar NaOH solution? Again, common ion effect. Again, what you are finding? A common ion effect. So here KSP is given. Solubility product of aluminium hydroxide is 2.4 into 10 power minus 24. Okay, so first of all, let us calculate. Let us understand that first, always we need to calculate in water. Aluminium hydroxide, AlOH taken thrice dissociates to form Al plus 3 plus 3OH minus, right? Now, where is this dissolved? This is dissolved in water first. This is dissolved in water, in pure water. So if the solubility of aluminum hydroxide is S moles per liter, okay, then aluminum concentration will be S moles per liter, and this will be 3S mole per liter, right? Then if you write KSP, okay, in a saturated solution, this is all in saturated solution. So KSP will be equal to Al plus 3 concentration into OH minus ion concentration. Aluminium is S into OH minus ion concentration cube. So 3S whole cube. KSP is equal. KSP is equal to S into 9 3 is 27 S power 3. Okay. Then what do you get? S is equal to KSP by 27 whole power 1 by 4. So KSP given already. How much? 2.4 into 10 power minus 24 by, okay, 27 whole power 1 by 4. So then what do you get? 2.4 by 27 whole power 1 by 4 into 10 power minus 24 whole power 1 by 4. 4 6 24. So 2.4 by 24 whole power 1 by 4 into 10 power minus 6 molar. Okay. So what is this solubility? So solubility is in the range of 10 power minus 6. Solubility is in the range of what? 10 power minus 6. Now let us come to actual question. Actual question is that in 0.2 m NaOH solution, that means along with this AlOH taken thrice gives rise to Al plus 3 plus 3OH minus. Along with this, NaOH solution is also there. Okay, NaOH is strong electrolyte, dissociates into Na plus and OH minus. Now you see. In this container, S moles per liter, yes, 3S, but here it is 0.2 molar and dissociates completely to produce 0.2 molar and it is 0.2 molar. Right? Now can you write KSP? KSP of aluminium hydroxide is equal to Al plus 3 concentration into what you write? Okay. OH minus ion concentration whole power 3. Now you write aluminium concentration is C, S plus Okay, yes. OH concentration, common ion is there, you see, common ion. That means 3s plus 0.2 whole cube Ks. Now, already we have calculated S. S is in the range of 10 power minus 6. S is in the range of 10 power minus 6. If you compare this 10 power minus 6 with 0.2, okay, S is in the range of how much? 10 power minus 6. Let us take 10 power minus 5. When you compare with 0.2, 10 power minus 5 is very much negligible. So I can take it as 3s plus 0.2 is almost equal to 0.2 because 3s is very much less than 0.2. So directly I can take it as 0.2. So now I can write it as Ksp is equal to S into 0.2 whole cube. S will be equal to Ksp by, so 2 into 10 power minus 1 whole cube. That is equal to Ksp already given to us. Ksp is given as 2.4 into 10 power minus 24. So 2.4 into 10 power minus 24 by 2 cube. 2 cube is 4, 4 to 8. 8 into 10 power minus 3. Okay. So what do you get now? I can write this as 24 into 10 power minus 25 into 10 power plus 3 by 8. 8 3 is 24. So 3 into 10 power minus 22. Solubility, molar. So solubility decreased or increased? It is in the range of 10 power minus 2. It is in the range of 10 power minus 6. Due to common ion effect, the solubility again is decreased. Due to common ion, see common ion effects. The common ion, who is common ion here? OH minus ion is common ion. So due to common ion effect, what has happened? Again solubility has been decreased. Whose solubility has been decreased? Solubility of sparingly soluble salt solubility has been decreased. Understood? So where is the answer? 3 into 10 power minus 22. So you will find answer here 3 into 10 power minus 22. When it is asked 2019. Okay. Let us move to the next question. Let us see this. The solubility product when it is given 2020 of chromium hydroxide at 298 Kelvin is 6.0 into 10 power minus 31. Then what is asked? The concentration of hydroxide ions in a saturated solution of chromium hydroxide is. Okay. The same procedure. So you can take considering water and the solubility product of chromium hydroxide at 298 is solubility product is given. What is asked? The concentration of hydroxide ions in a saturated solution of chromium hydroxide is asked. Okay. So let us see that. Saturated solution, let us take saturated solution. Saturated solution of chromium hydroxide produces chromium ions and OH minus ion. Okay. So this is, he did not ask in any solution. He asked simply only chromium hydroxide. That means it has been dissolved in water. In pure water, this dissociation is in pure water. Okay, when S moles, if solubility of chromium hydroxide is S moles per liter, what will be chromium ion concentration? S mole per liter, and this will be 3S mole per liter. Okay, then let us write KSP for this. KSP is equal to Cr plus 3 ion concentration into OH minus ion concentration whole power 3. Chromium ion concentration is equal to S, and OH minus ion concentration is equal to 3S whole cube. Okay. So that is equal to S into 27, 3 3 is 9, 9 3 is 27, S cube, right? KSP is equal. So KSP is equal to 27 S power 4. Okay. 27 S power 4. So now S is equal to KSP by 27 power whole power 1 by 4, right? So KSP how much is given? It is given as 6 into 10 power minus 31. 6 into 10 power minus 31 by 27 whole power 1 by 4. So we know S now. So what is the question asked? The question asked is the concentration of OH hydroxide ions. So this hydroxide ions. So concentration of OH minus is in a saturated solution is 3S. That is equal to 3 into S we have calculated as how much? 6 into 10 power minus 31 by 27. 6 into 10 power minus 31 by 27 whole power 1 by 4. Okay. If you convert this 3 into power of 1 by 4, then I can write it as 27 fours, 7 fours. So 27 3 is 81, right? So if I take 81 power 1 by 4 into 6 into 10 power minus 31 by 27 1 by 4. Okay. So 3 can be written as 81 power 1 by 4 because 3 into 3 into 3 into 3, how much? 9, 9 3 is 27, 27 3 is 81. Okay, so this 3 can be written as 81 power 1 by 4. Understood? So now I can write it as 81 into 6 into 10 power minus 31 by 27 power 1 by 4. Complete power 1 by 4 because 81 power 1 by 4 and this 6 into 10 power minus 31 by 27 1 by 4. So completely I can write. Now I can cancel 27 3 is 81. 3 6 18. 18 into 10 power minus 31 power 1 by 4. So OH minus ion concentration, what did you get? 18 into 10 power minus 31 power 1 by 4. Understood? So is there the answer 18 into 10 power 18 into 10 power minus 31 whole power 1 by 4. So this is the answer. Got the answer. You can find the answer on screen 2020. Understood? If you see PYQ from the chapter ionic equilibrium, more questions you will find from this concept of common ion effect, solubility, products. So we should more concentrate on this particular concept when coming to the case of preparing for competitive examinations. More the problems we solve, more practice you do, more easy it will be in the examination. The thing is that you should understand the concept. After understanding the concept, you need to practice. Simply understanding concept is not sufficient for the competitive examinations. You need to practice. right? In the next session, we shall solve some more questions on the solubility and solubility product. Now let us wind up this session. Thanks for watching. Let us meet in the next lecture.